All right, so welcome back for lab 3. So in the first two labs, obviously we did the bones of the shoulder girdle, and then we did the muscles of the shoulder girdle and pulled that all together. So for labs 3 and 4, what we're going to do is the bones from where we left off with the shoulder distally. So we're going to do everything from the elbow down, essentially. So you can see my zoomed out picture there. So what we're going to cover here in lab 3 is the osteology, again, the study of bones. In this case, we're going to do the distal aspect of the humerus, the radius, the ulna, the carpal bones, and then all the bones of the hand. So what you're looking at here, as always, is the right side of the body. So you've got the right elbow on down, so distally. So then we've got the distal aspect of the right humerus, and then in terms of the other bones here, so this bone, the more medial of the two in the forearm, is the ulna, and then the radius is the more lateral of the two. Again, we're always going to start in anatomical position. So in anatomical position, then, the radius is the more lateral of the two. One of the other ways to think about it is that the radius is on the thumb side of the hand, and that the ulna is on the pinky side of the hand. So what we're going to do then is zoom in just a little bit. So there's a slightly closer view. Now we're going to zoom in a lot and be on just the distal aspect of the humerus, and then the proximal aspect of the ulna, which is where my arrow is, and then the proximal aspect of the radius here. So on the lab 3 sheet, the first set of rows is the distal aspect of the humerus. So it's the part of the humerus that we hadn't covered yet. So the first landmark on there is the medial supracondylar ridge. So remember that supra means above. The condyles in the humerus are a little bit harder to define or harder to find than you're going to see when we get to the femur. But essentially the medial condyle is all of this area that I'm outlining with my mouse here. The lateral condyle is over here. So the medial supracondylar, so again above the condyle, and then a ridge is all of this area. So the medial supracondylar ridge is all of this. And then if we move down a little bit, or distally a little bit, we'll get to the medial epicondyle. That's going to be a really important landmark. It's also a really obvious landmark. So in your own elbow, if you look at the medial aspect of your own elbow, you'll notice that there's a pretty big knob there on the inside of your elbow. That's your medial epicondyle. The other thing about it that's important is when we get to the muscles, we're going to talk about two groups of muscles. And the first is the wrist flexor and pronator group. So if you flex your wrist, what you're going to do is take the palmar aspect of your hand and bring it closer to your forearm when you're in anatomical position. So take the front of your hand, bring it closer to your forearm. That's wrist flexion. As opposed to wrist extension, take the posterior aspect of your hand, bring it closer to your forearm. With wrist extension, that's how you would catch yourself when you fall. So that's a pretty common posture. So if you reach out to try to catch yourself, that's going to be wrist extension. And then wrist flexion, obviously, is just the opposite. So where that ties back into the medial epicondyle is that the muscles of the wrist flexor and pronator group originate there. So remember that pronation is flipping your forearm over so that your palms face posteriorly. So the wrist flexor pronator group originates there. That's also the site where we're going to get one of the syndromes involved with Little League elbow. And effectively what happens there is you have a growth plate, which is where I'm mousing over right now, that's underneath the medial epicondyle. And in Little League pitchers that basically pitch too much without enough rest, what ends up happening is that they overuse that wrist flexor group, and that muscle specifically is called pronator teres. That's part of that group. And so pronator teres, one of the things that it does in addition to pronation is it helps stabilize the medial aspect of the elbow. I'll show you in class what ends up happening during a throwing motion, but effectively your forearm gets pulled away laterally, kind of like I'm directing my mouse right now, gets pulled laterally away from the midline, and that then puts a tensile or pulling apart stress on the medial aspect of your elbow, and so that group of muscles, the flexor pronator group, will start to pull away from the medial epicondyle there, and you'll get a separation of the growth plate. So you can also get an inflammation there of that group, medial epicondylitis. It's more colloquially known as golfer's elbow, and so that's a combination of wrist flexion and pronation can lead to an inflammation of the tendons of the muscles that originate there. So that's your medial epicondyle. Again, the short thing to know, wrist flexor pronator group originates there, pretty obvious and pretty prominent landmark. The next one is the trochlea. So the trochlea, you're going to want to watch the mouse, but the trochlea is the medial aspect of the distal humerus. So all of this area that I'm boxing around with my mouse, all of that is the trochlea. When we get to the lab and you see the bones in front of you, it actually kind of looks like a spool that you would put thread on. And the trochlea, the thing to know about it is that it's going to interact with the ulna, and you can see those two interacting here. So the trochlea and the ulna go together, and then just above, or just proximal to the trochlea, is the coronoid fossa. So you can't really see it on this essential anatomy drawing, but there's an indentation right here, proximal to the trochlea. And the reason that's there, again, that's the coronoid fossa. The reason that's there is you've got this projection on the ulna called the coronoid process, and when you flex the elbow, which means to bend it, so when you flex the elbow, the coronoid process down here at the ulna falls into the coronoid fossa of the humerus up here. So that's why the coronoid fossa is there, to clear space for this coronoid process. So then the next thing, we're going to move laterally. The next thing that we've got is our capitulum. So the capitulum is this golf ball shape on the lateral aspect of the distal humerus. So all of this then is the capitulum. And it'll be really obvious when I say golf ball shape. You'll see that more prominently or very obviously when we get to the lab. It's very spherical in shape. At any rate, the capitulum, or the lateral aspect of the distal humerus, is going to interact with the head of the radius. So the capitulum and the radius go together. I don't really have any good way to remember that other than the fact that trochlea kind of sounds like ulna, and then the other two, I don't have anything for you. The capitulum and the radius don't sound anything like each other, but the trochlea and the ulna go together, and the two kind of sound alike, so hopefully that'll be helpful for you. At any rate, the capitulum's here, and then just proximal to the capitulum, I skipped over one, but you've got the radial fossa. So the radial fossa is right here. Again, not super obvious on the essential anatomy diagram, but it's an indentation here just proximal to the capitulum. The radial head kind of looks like a golf tee, and so again, when the elbow is in full flexion, the radial head is going to drop into the radial fossa, which is why that indentation is there. All right, so going back to the one I skipped over, our lateral epicondyle is there. So the lateral epicondyle is this little projection right there. Again, so it's obviously analogous to the medial epicondyle over here, but obviously not nearly as large. So the lateral epicondyle gives rise to the antagonistic or the opposite group of muscles that we saw on the medial epicondyle. So if on the medial epicondyle you've got the wrist flexor pronator group, then you just flip everything on the lateral epicondyle. So then on the lateral epicondyle, what you've got is the wrist extensor and supinator group. So you got one muscle that originates there, supinator, which obviously causes supination, and then the rest of them are going to be wrist extensors. So the wrist extensor supinator group originates there at the lateral epicondyle. We talked about the radial fossa, and then we'll move proximally, so moving up the bone, to the lateral supracondylar ridge. So that's all of this. So again, analogous to the medial supracondylar ridge, but we're on the lateral aspect. So all of this is the lateral supracondylar ridge right there. And then the only other landmark on the distal humerus is the olecranon fossa. So now what we've done is I've switched views. Now you're looking at a posterior or back view of the distal humerus and the olecranon fossa. You can't see it all that well because the ulna is in place here, but we used it as one of the landmarks to identify side in the humerus. So remember, the olecranon fossa is that very large indentation on the posterior aspect of the bone. Same idea with the olecranon fossa that we saw with the coronoid fossa and the radial fossa. You've got an indentation there that the olecranon process of the ulna is going to fall into, in this case, when the elbow is in extension. So those are all the landmarks of the distal humerus. In terms of side, in terms of doing right and left, again, we did that with the shoulder, but remember that the way that I would do that is to have either the humeral head or the medial epicondyle, because it's pretty obvious and prominent as well. Have those landmarks facing medially, and then have the olecranon fossa on the posterior aspect. So again, the way I said it in class was the big hole, put that in the back. So medial epicondyle facing medially, olecranon fossa facing posteriorly, and then you know that you have, in this case, a right. All right, so then moving on from there to the ulna. So what you're looking at here is a medial view of the right elbow. So you're looking at the inside of the right elbow, because that's going to make some of these landmarks on the ulna stand out and be a little more obvious. So the first landmark on there is the olecranon. One of the ways to think about the olecranon is it's essentially the tip of your elbow. So when you flex your elbow, which again means to bend your arm, you've got that really prominent point on your elbow. That's your olecranon. So that's part of the ulna. And so then all of this posterior aspect is the olecranon of the ulna. So again, if you flex your elbow and you feel your olecranon, it's going to be this area of the bone. So that's the olecranon. And then the next thing is the trochlear notch. So the trochlear notch is all of this half moon shape here. So the trochlear notch, as you would expect, interacts with the trochlea of the humerus. So the trochlear notch of the ulna goes with the trochlea of the humerus, and that helps form the primary hinge joint of the elbow, which is the Humeroulnar Joint. So all of that half moon shape there is the trochlear notch. On the most distal aspect of that is going to be the coronoid process, and I mentioned that earlier with the coronoid fossa. So this anterior lip, and I guess if you want to go with distal lip of the trochlear notch, all of that there is the coronoid process. So there's your coronoid process right there. Again, it'll fall into the coronoid fossa whenever you flex your elbow. Then we've got the radial notch of the ulna. So to get to that, we're going to go to the anterior view. So again, anterior view of the right elbow. There's our coronoid process that we were just pointing out. And then the radial notch is this little indentation right here on the ulna, into which the head of the radius fits. So the head of the radius is going to sit in the radial notch of the ulna. So it makes a space there for the radial ulnar joint. So that's a joint whenever you, we've talked about pronation, supination, where your palm is facing forward in supination, or your palm is facing posteriorly in pronation. Where that spinning occurs, or where that flipping over of your forearm occurs, is going to be at the radial ulnar joint. So there's one here proximally, this is the proximal radial ulnar joint, and then there's one distally down closer to your wrist. So the ulnar, the radial notch of the ulna then makes the space for that. The next thing is going to be the ulnar tuberosity. So the ulnar tuberosity is a little rough area, and you can kind of see it on the essential anatomy drawing. It's a little rough area right here. One of the elbow flexor muscles, brachialis, is going to insert near there, although it also inserts along the coronoid process as well. So the ulnar tuberosity is this little rough area right here on the proximal aspect of the ulna. So then the only other landmark that we've got on the ulna is distal. So now we've zoomed out a little bit, still looking at the right elbow from the anterior aspect, but now we're going way down here, closer to the wrist, and you see this little point down here close to the wrist. That is the ulnar styloid. So styloid, what that term means is resembling a column. Kind of looks like a little pillar extending from the ulna. So there's your ulnar styloid. You have an ulnar collateral ligament of the wrist that is going to originate near there and helps protect the wrist from, it keeps your hand from being pulled away from the midline, is one of the things, or the primary thing that it does. So your ulnar styloid is there. So in terms of doing right and left with the ulna, the things that I look at, number one, and the most straightforward thing, is going to be that your olecranon has to be on the posterior aspect. So put the olecranon in the back, and then the other thing that I look at is the radial notch. So the radial notch, again, is this indentation right here. It'll be really obvious and really prominent when you get to the bones in class, but the radial notch needs to face laterally, so it needs to face away from the midline. One of the ways to remember that, so you're aware by now that the ulna is the medial bone, the radius is the lateral bone, so then the radial notch has to face laterally where the radius is. So put the olecranon in the back, make the radial notch face laterally, and then that'll determine right and left in the ulna. So those are then landmarks for the ulna. Then we move on to the radius. So again, we've got the anterior view of the right elbow. The radius is pretty straightforward. So you've got, if you notice, the proximal aspect of the radius kind of looks like a golf tee. And so you've got the radial head, which is all of this, that top part of the T. And you can see it's covered in that hyaline, that smooth cartilage. That's why it has that slightly different color, that kind of grayish color, and looks shiny, is because it's covered in that hyaline cartilage. So all of this then is the radial head. The area where it narrows just below the head, right through here, is the neck. Again, pretty straightforward. And then the next thing, which is on the top of the second page, is going to be the radial tuberosity. So the radial tuberosity is this bump just distal to the neck of the radius. So this pretty obvious bump or protrusion right there, that is the tuberosity of the radius. The significance of that landmark is that's the insertion of biceps brachii. So that's a pretty important landmark. If somebody has a distal biceps tear, so one of the things about biceps is it's a muscle in the shoulder that tends to rupture fairly frequently in a variety of sports, anything from a throwing sport like baseball to your strength sports like strongman, especially when they do things like carry the stones, you can get biceps rupture. So you can get either a distal rupture, in which case it ruptures down here, and effectively what ends up happening then is biceps will pull away from this radial tuberosity and then it'll roll up on itself. And so actually the surgery for that, they'll take that tendon and actually screw it back through the bone and through that tuberosity. So the thing to know about that area then, biceps brachii inserts there. Then we got the radial styloid. So we're going to go distally. So now you're looking at the posterior aspect. You're looking at the back of the right hand. And so we got two landmarks on the distal aspect of the radius. The first is the radial styloid. Again, styloid means resembling a column or resembling a pillar. And so this area right here, again, it'll be a pretty obvious projection in the lab, but that's your radial styloid. Your radial collateral ligament will originate there, and it'll keep you from pulling the hand toward the midline too far. So it protects the hand against side-to-side stresses. So that's the radial styloid. And then, not super obvious on this, but kind of, it is really obvious on the bones in the lab. You'll see this series of ridges on the posterior aspect of the distal radius. That's the dorsal or Lister's tubercle. And so that's one of the landmarks that I'll use for right and left in the radius. And so what I'll do when I want to determine right and left is I know that that set of ridges, the dorsal tubercle, has to be on the back, because remember that dorsal and posterior mean the same thing. So the dorsal tubercle, you got to flip that toward the back. And then the other thing that you know is that in anatomical position, the styloid has to be on the lateral aspect of the bone. So if we flip the dorsal tubercle toward the back, toward the posterior aspect, and the styloid toward the lateral aspect, then that'll tell us right and left in the radius. And that's it for the radius. So the radius is pretty straightforward, kind of like the clavicle was. So then we move on to the carpal bones. So the carpal bones are 8 bones that form your wrist. And effectively one of the ways to think about the carpal bones is as 2 rows of 4. So there's a proximal row that starts here, runs through these 4. So there's 1, 2, 3, and 4. So that's our proximal row of carpal bones. And then we've got our distal row of 4 that starts here at the thumb and then runs this way back toward the pinky. So the way that we're going to discuss them then is as those 2 rows of 4, we'll start with the proximal row, and we're going to start on the thumb side of the hand right here, and then we'll move back medially, and then we'll start over at the thumb side of the hand and then move back medially. So the first of the carpal bones is our scaphoid. So that's the one that I'm circling right here. So the scaphoid, it comes from the Greek word scapheides, which is a word for boat. If you look at it in class, it kind of looks, it has sort of a U shape to it. And so the idea was that it kind of looked like a boat. It's also called the navicular. There's a bone in the foot that's also called the navicular as well. So I tend to call this one the scaphoid just to avoid confusing you. The navicular, for what it's worth, comes from the Latin word for boat. So in this case, Greek word. In the case of the foot, Latin word. But they both mean boat. And so because both of the bones, some anatomists thought were shaped like a boat. So there's your scaphoid right there. It's the most commonly fractured of your carpal bones, because when you fall on an outstretched hand with the wrist and hyperextension, it tends to basically get pinched between the distal radius here and then that distal row of carpal bones right there. And so then it tends to fracture kind of through the middle part right there. So that's your scaphoid. And then we've got our lunate, which is right here. So lunate, the name comes from the shape of the bone, kind of looks like a half moon. Luna is moon. And so again, it's going to have a fairly obvious C shape to it when you look at it in class. But the lunate, again, right next to the scaphoid over here. So this is the lunate. And then continuing laterally, so you've got the triquetrum. Triquetrum means 3 corners. So it kind of has 3 corners to it. The lunate, one of the things I didn't mention about it is it's the most commonly dislocated of the carpal bones. So if you use the same mechanism that you would use to fracture your scaphoid, where you fall on an outstretched hand, doing that mechanism can result in an anterior dislocation of the lunate. And basically it'll pop forward, and when it does that, their wrist will be stuck in hyperextension, and oftentimes they'll get a tingling or numbness into their second and third finger, so like into their ring finger and middle finger, because that bone sits underneath the carpal tunnel, and the median nerve runs through that carpal tunnel. So if that bone gets dislocated, it'll then press on the median nerve, and that can cause some tingling and numbness down here. So that's the lunate, most commonly dislocated. Again, then we've got the triquetrum, the 3-corner bone. Nothing super exciting happens to it, really. It's higher in the incidence of fractures, but it's a fairly uncommon injury to fracture that. Then the next one's the pisiform. So this little guy right here is the pisiform because it's shaped like a pea. It's one of the interesting things about it, it's a sesamoid bone, which means that it's a bone in a tendon. But gotta go back. So it's a bone in a tendon. And so one of the things, if you look at the palmar aspect of your hand, on the pinky side of your hand, you'll notice that there's a pretty obvious kind of a 90-degree angle to your hand. And so right there at that 90-degree angle is where your pisiform is. And you can actually pinch on either side of it. And then if you let your wrist relax a little bit, you can actually slide this bone left and right because it sits in a tendon. The particular muscle in whose tendon it sits, that muscle is Flexor carpi ulnaris. So that's your pisiform bone. So then we go from there. So that's our proximal row of 4. So scaphoid, lunate, triquetrum, pisiform. Now we're going to go back to the distal row. So starting back over on the thumb side, we're going to go to the trapezium. So the trapezium is right here. So one of the important things about the trapezium is its shape on the distal aspect here. So the shape of the distal aspect is referred to as being saddle-shaped. If you've seen a horse saddle at some point in your life, you know that it is concave front to back and then convex side to side. And you get a complementary shape there on the proximal aspect of the first metacarpal, so this long bone of the thumb. And so because of that, because each of these surfaces is saddle-shaped, that allows that joint to move in 2 planes. So that allows us to flex and extend the thumb, but also to abduct the thumb, which is kind of to bring it toward the palmar aspect of your hand up this way, which then allows us to oppose, which means to take your thumb and then bring it together with all your other fingers. So if you oppose, you can make kind of the OK sign, or you can bring your thumb to your middle finger, ring finger, etc. And the important part about that is that ability to abduct the thumb allows us to grip things, allows us to grasp. And so the shape of this joint is really, really important. So that is the first carpo-metacarpal joint, or CMC joint is the abbreviation. The rest of the carpo-metacarpal joints, you're not going to get much movement. So the rest of them we don't ever really talk about. But the first carpo-metacarpal joint is really important because, again, that's going to allow for that 2-plane motion, allows for flexion extension and ABA deduction, which gives us the ability to grasp things. And again, that's on the trapezium. Then the next one's the trapezoid, much less exciting. The trapezoid interacts with the second finger, which is your index finger, or at least with the metacarpal of it. So that's your trapezoid right there. And then we've got our capitate, which is this one. Capitate's pretty big. It has a fairly large head, and capitis is head, so it's named that because of its big head up here on the proximal aspect. Again, not a whole lot exciting with the capitate. Then we've got the hamate, which is this one. So you'll notice that the hamate interacts with your 4th and your 5th fingers, which are your ring finger and your pinky, respectively. So all of that then is the hamate, interacts with 2 of the metacarpals. The other thing to know about the hamate is that it's got this pretty obvious projection right there, which is called the hook of the hamate. and I'll show you how to find that in class if you're interested. But the interesting thing about the hook of the hamate is that's an area that tends to get fractured. So if you fall on an outstretched hand, or if we also see that in like implement sports. So if you're holding a golf club or a baseball bat or something, and you strike something really solid that vibrates that implement a lot, that vibration force can cause a fracture there. So that's part of the reason you see, like in baseball, the axe handle bats, you see baseball players with little donut-shaped pads on the palm of their hand. That's part of the reason they do that, is to avoid fractures of the hamate, because there's usually a couple guys every season that end up with that particular injury. The other thing is that between the pisiform here and the hook of the hamate there, that's called the tunnel of Guillain, this area between those two, and you've got your ulnar nerve, which supplies the fourth and the fifth fingers, so your ring finger and pinky finger. That ulnar nerve runs through there, and so sometimes people can compress the ulnar nerve through that tunnel, especially if you're like a cyclist and you sit with your hands on the handlebars for a long period of time. It can cause tingling and numbness in the fourth and fifth fingers from compressing there in the tunnel of Guillain. So those are our carpal bones then. Again, we always start on the thumb side and then move medially with our proximal row of 4 and then go to our distal row. So scaphoid, lunate, triquetrum, pisiform, trapezium, trapezoid, capitate, hamate. One of the things I would say, so obviously you've probably noticed by now that there are 3 T's. So there's triquetrum, trapezium, and trapezoid. The way that I remember them is that the ums go together, so triquetrum, trapezium. I don't know if that helps you, but that's how I remember them. So the ums end up going together. All right, so then the next thing are the bones of the hand. So with the bones of the hand, you've got a couple groups. So you've got the metacarpals here. So the metacarpals are the long bones of the hand, and there are 5 of those. I've been using the numbers of the digits, but I haven't explained to you what those are, so I probably should do that. So the way that numbering of the digits works is that your thumb is number 1, and your pinky is number 5. So then this is the first metacarpal, the long bone of your thumb. Second metacarpal, the long bone of your index finger. Third is your middle finger. Fourth is your ring finger. And then your fifth is your pinky. So those are the metacarpals, are the long bones of the hand. Then we've got our phalanges. So the thumb has 2. There's a proximal and a distal. And then all the rest of the digits, so digits 2 through 5, have 3 phalanges. So there's one there, the proximal one of the second digit, the middle or intermediate of the second digit, and then the distal of the second digit. So the singular version of that is phalanx. So one individual bone, so this is a phalanx, and then plural is phalanges. So these are 3 phalanges. The name comes from ancient Greek fighting formations. So basically if you have seen 300, I know it's kind of a dated reference now, but you've probably noticed that one of the ways that the ancient Greeks fought is that they would have this overlap of shields. So you have basically this big rectangular formation, an overlap of shields, and then they would drop spears over the top of those shields and basically then kind of stab out like that. So they're sort of this big walking armored rectangle. And so one individual unit is called a phalanx. And then if you look at the Greek army as a whole, there would be one phalanx next to another phalanx next to another, and then with phalanxes or phalanges behind them. And so if you then look at the Greek army again as a whole, it would kind of have this appearance of one rectangle next to another rectangle with ones behind them, so that they could reinforce if things didn't go well for the rectangles there in front, for the phalanx in front. Then you'd step up and replace. And so that's why they're called a phalanx or phalanges, is because they resembled the Greek army. That's where the name comes from. So again, in the case of the phalanges, your thumb has 2, proximal, distal. Digits 2 through 5 have 3, a proximal, middle or intermediate, and distal. And so those then are the phalanges. All right, so let's then talk about joints to bring it home. So in terms of the joints then, maybe see if I can move ahead or back on my slideshow. Hold on. There we go. Oh, maybe not. There we go. Okay. Figured out the technical error. All right, so let's talk about joints. So, in terms of the joints, remember that joints describe the bones that interact. So, one of the things I've got on there is the bones that articulate, but usually it's right in the name. So, for example, the first joint there is the Humeroulnar Joint. So, again, that's the interaction between the distal aspect of the humerus, specifically the trochlea, and the ulna, specifically the Trochlear Notch of the ulna. So, the Humeroulnar Joint is here. That is a hinge joint. You've noticed from the shape of the trochlear notch that the ulna wraps around the humerus and forms a pretty solid hinge there. And so you're only going to get two actions there at the humeroulnar joint, which are flexion and extension. So that's a hinge joint. So you get flexion, which is bending the elbow, extension, which is straightening the elbow. So you've only got one plane, 1 degree of freedom, which is the sagittal plane. So flexion, extension, sagittal plane. Those are the only only actions, and then the only plane of motion there at the humeroulnar joint. Then the next one, we've got our radial ulnar joint. So then that's the interaction between, and I skipped over one, sorry, we'll come back to the other one. So our radial ulnar joint is the interaction between the radius and the ulna. So the radial ulnar joint is right there. So radius ulna. And so that is a pivot joint. It also only moves in one plane. So effectively what happens there is that the radius spins on the ulna. And so when it spins this way, so when it spins medially, then you get pronation. When it spins laterally or externally, then you get supination. So only one plane there, 1 degree of freedom at the proximal radial ulnar joint. Going back a little bit to the one I skipped over. Again, apologies for that. Then we've got the humeroradial joint. So that's the interaction between the capitulum on the humerus, so that lateral aspect of the humerus, and the radial head. That's our humeroradial joint. That's also a hinge joint, only moves in one plane. So just like the humeroulnar joint, all we get at the humeroradial is flexion and extension. So if I ask you about muscles that are flexors or extensors at the elbow, let's say biceps brachii, for example, and I ask you about the joint at which that action occurs, what I'm looking for is humeroulnar, because that's the primary hinge joint of the elbow. But if you say humeroradial, it's not technically incorrect, but a better answer is humeroulnar. So if you're talking about elbow flexion or extension, the joint at which that action occurs is the humeroulnar joint. All right, which then brings us down to the wrist. So the name for the wrist joint is the radiocarpal joint because it's the interaction between the radius, and you'll notice down here the distal aspect of the radius is much larger than the proximal aspect, so all of that is the radius. So the interaction between the radius and the carpal bones, most specifically between the radius and the scaphoid and the radius and the lunate, that's your radiocarpal joint, which is your wrist joint. At that joint, that's actually referred to as a condylar joint. You get two planes of motion. So you get wrist flexion and extension that we've already talked about. Again, flexion, take the palmar aspect of your hand, bring it closer to your forearm. Extension, take the posterior aspect of your hand, bring it closer to your forearm. So again, extension is how you would catch yourself if you fall. The other two motions, though, look a lot like adduction and abduction, but they're called something different at the radiocarpal joint. So if you, in anatomical position, bring your pinky closer to your body, which is going to look like adduction, it's actually called ulnar deviation. So ulnar deviation, take the pinky side of your hand, bring it closer to your forearm, and then the opposite, as you'd imagine, is radial deviation. Take the thumb side of your hand, bring it closer to your forearm. So again, it's going to look like abduction. But because we've got those four total motions, flexion, extension in the sagittal plane, and then radial and ulnar deviation in the frontal plane, that gives us 2 degrees of freedom because we're moving in 2 planes there. Then we've got our metacarpophalangeal joints. So we're going to primarily concern ourselves with digits 2 through 5 here. So the metacarpophalangeal joints of digits 2 through 5 are in this area that I'm boxing in right there. So with the metacarpals, you've got the bases more proximally and the heads down here more distally. When you make a fist, the area that pokes up is part of the heads of the metacarpals. So the interaction between the metacarpal and the proximal phalanx of each of these digits is going to be the metacarpophalangeal joint. So again, here I'm looking at the second metacarpophalangeal joint. All of those are also condylar joints that move in two planes. So in digits 2 through 5, you can flex the fingers, which means to make a fist. You can extend the fingers, which means to straighten them. So you can do that, the MCP joints. But the other thing you can do with the MCP joints is abduction and adduction, which means to abduction is spreading your fingers, and then adduction is bringing them back together. So you can do that, those joints as well. So then, just like the radiocarpal joint, you're going to get flexion extension, sagittal plane, and then AB adduction in this case, frontal plane. So 2 planes of motion, 2 degrees of freedom at the metacarpophalangeal joints. Then the next thing, or the last thing, are the interphalangeal joints. So inter is between, so interphalangeal is between the phalanges. So between our proximal phalanx and our middle phalanx is an interphalangeal joint here. And at each of the interphalangeal joints, all you get is flexion and extension. So you can bend the finger and you can straighten the finger. So the one that's closest to the body is the proximal interphalangeal joint, is the one that I'm circling here. The abbreviation is PIP, proximal interphalangeal. And then the one that's far from the body, this one right there, is the distal interphalangeal, or the dip joint. So that's it. And then the thumb, because it only has 2 phalanges, only has 1 IP joint. So it's just referred to as the interphalangeal joint of the thumb. And then the thumb's metacarpophalangeal joint, all you get there is flexion extension, so that's why we didn't talk about that one. If you're curious, these 2 little guys are called sesamoid bones as well, just kind of like we talked about over here with the pisiform. They don't have separate names though, they're just sesamoid bones in the thumb, little bones in the flexor tendon. So that's what those are. So the IP joints are all hinge joints that only allow for 1 plane of motion. They only allow for flexion extension, again in the sagittal plane. So all of the IP joints then have 1 degree of freedom. So that's all of the osteology for the elbow, the wrist, and the hand. And so we'll go through some of those motions in lab for this week. And then next week we'll move on to the muscles.